which is a pulley system. And this will be a cam. Now, the next is a wedge. Now, in using a wedge, you're pulling along a surface. Hand, monkey, hey, here, my crotch. As you pull along a surface, he's moving with angulation. As he moves along that, we have greater efficiency. It's easier to move an object along an angle than it is to lift it directly. So if we use this as a fulcrum and pulling this arm backwards, we have greater efficacy if we move up along the wedge. Plus, this is going to help us later in sinew separations because it's going to act as a variable fulcrum. This is going to be super important. The final simple machine that we're going to be exploring is a screw. Now, screwing submissions, most people understand. However, they don't understand, and I see it's so incorrectly applied everywhere because they try and move into force instead of understanding the anatomical structure rather than the mechanical structure. Can you stand up?
Maybe.
Thank you. Please stand up quick. Now, in IOUF, immovable object unstoppable force, we discussed this in terms of his femur. This was a great example because the way the femur is constructed, it's actually at an angle, and then the head goes into the acetabulum of the pelvis. The mechanical rotation of this bone is along his leg. Right now, if the way it's constructed, it would rotate around itself without any displacement. But the anatomical rotation is around this angle. This is what we call hyperfunction. Can you lay down again? Now, understanding this screw, when you know how for instance, with the humerus bone. The humerus bone, again, has this weird, funky angle because the trochanter and it goes into this joint. And this whole shoulder girdle complex is pretty neat. But if you rotate on the anatomical axes of the joints, you're going to facilitate his motion. If you rotate in the mechanical axis, don't let me pull back. The mechanical axis, he has strength. On the anatomical axis, he doesn't. Just in understanding how the bones are connected and where the bones are connected, you're going to facilitate his motion. You're going to deconstruct his force through the strategy of hyperfunction. This is what hyperfunction is at an anatomical and physiological level. So, in review, we have a lever, we have a pulley, we have a wedge, and we have a screw. Those four simple machines will be the last end of the formula for us to improvise and innovate techniques infinitely for the rest of our lives in anything we do, forever. You've come to the conclusion of this installment of Arthrokinetics. Now, again, we like to emphasize that you have to moderate safety, moderate intensity, and moderate your exploration. If you're dealing with the four strategies of joint manipulation, immobilization, submission, hyperfunction, and dysfunction, your goal should be to explore in a safe environment. Your performance cannot be increased at the expense of your partner. Again, for future installments, look for spinal and neck architecture, for the architecture of chokes and strangulations, for reversals and escapes, and for combinations and flow. We didn't cover in this series entries because we want you to look forward to explorations. All of the entries have been done before in various tape series of assorted kinds. If you're looking for tricks, then go to reputable instructors like Igor Yakimov, Tony Cicchini, Eric Paulson. They have excellent materials and they've been proven to be excellent instructors. Use all of the techniques that you can find, explore them, and incorporate them into your comprehensive or your global appreciation of arthrokinetics. because this is the science of submission fighting. This is the biomechanics of joint manipulation. What a great audience, very much.